And welcome everybody to the Daily Space Weather. I'm your host Dan, aka smAsho, and now I'm shrinking down to a smaller size. There we go, that's better. Today we're talking about coronal hole, a pretty large one. Coronal mass ejection. Volcanoes have upticked. We'll be talking about protons once again, and Voyager. First thing we ought to do is look at the sun. Today we're looking at 211 angstroms from the SDO. You can see this large coronal hole right here. And we don't always show the 211 angstroms view. Today we did because of that feature. It's just north of sunspot 2790. The 10.7 centimeter radial flux now at 103 solar flux units. There's the 1 year chart of sunspot number and AP index and the 10.7 centimeter radial flux. And there's cycle 24 and the beginning of cycle 25 from the Space Weather Enthusiast dashboard. We're going to take a quick look at the fields here. There's 171 angstroms. There are the fields. And this area right here is not a sunspot. We don't see any umbrae, at least I didn't earlier. And here's 304 angstroms. A nice fade, a nice orangey, golden orangey sort of a color thing going on there. Again, we did see a coronal mass ejection, and we'll let you know later whether or not it's Earth facing. Here's one of our HelioViewer movies, showing you a limited view here from the LASCO C2 as well as the 304 angstroms SDO, the LASCO being part of the SOHO spacecraft. And we'll show you some more of those HelioViewer movies toward the end of the video. Please press like and subscribe if you enjoy the content. Share the content in your social media if you enjoy the channel. Don't forget to watch our smAsho.org Presents the Sun videos, such as the one we put up on Sunday, featuring the massive M-class solar flare and accompanying coronal mass ejection, as well as numbers 1 through 9, which are all accessible at smAsho.com. Thanks to our BitChute subscribers also, as well as to Twitch, which is where we are streaming live right now, twitch.tv/smAsho, and let's talk cosmology. No need to roll dice today. We've got an interesting story here about the magnetosphere of magnetar Swift J1818.0-1607. I know it's a catchy name. Swift J1818.0-1607. And this article is at phys.org in the astronomy and space section. It's also a gamma ray repeater, and this one's important in terms of the angle at which it is viewed from Earth. Magnetars are one of the more interesting objects out there. And the magnetic field strength is estimated to be at 250 trillion Gauss. And I'll just let this scroll real quick. Feel free to pause and read the article if you like. It's at phys.org in the astronomy and space section. Even more interestingly is some electron accelerated cosmic ray flux happening at Voyager 1 and Voyager 2. So this was more of a theoretical thing until it was actually measured. So it takes more than a year for solar outbursts to reach Voyager 1 and Voyager 2, as they are outside of the heliosphere. And it's pretty interesting to see that the theoretical acceleration of electrons and cosmic rays as a result have been measured out there. So this one is on SciTech Daily. I'm sure this will be all over the Science Wire coming soon. And let me just read a quote here. The idea that shock waves accelerate particles is not new. It all has to do with how it works, the mechanism. The fact that we detected it in a new realm, the interstellar medium, which is much different than in the solar wind where similar processes have been observed. No one has seen it with an interstellar medium shockwave in a whole new pristine medium. Again, that one is on SciTech Daily. The title, Unique Physics in Interstellar Space. Voyager spacecraft detect new type of solar electron burst. Now, we talk about cosmology regularly, and one of the ways that we are sort of advancing the science here is at smAsho.com. Check out our social media links. We talk about all kinds of other stuff in addition to daily space weather. Also check out the smAsho forum and the smAsho stores. And if you go to the smAsho stores, for instance this one, if you purchase any items at either of our stores, make sure you enter the promo code smAsho at checkout to save 10% on all orders through Christmas. And we regularly do cosmology segments. This one will be integrated into the daily space weather video. Here's some more data for you. It's the real-time solar wind, and it's dropped off a cliff. We see extremely low solar wind densities, some of the lowest we've seen, making it all the way down to 0.1 protons per cubic centimeter. And you can see that the bottom part of the scale there has even expanded in order to accommodate those extremely low measurements from ACE and Discover. Two spacecraft orbiting Lagrange point 1, which give us about an hour of lead time before those protons strike the magnetosphere. Current solar wind density, incredibly low, at 0.19 protons per cubic centimeter. Solar wind speed, background levels 354 kilometers per second. And this is just a view of the solar system here. I just brought this up when I was looking at the NASA and Discover websites. We will talk about the Parker Solar Probe sometime soon, and you can see where that is on the diagram there. I like it. You can move it all around. I won't move it all around because it'll look really crazy during the live stream, and we don't want to do that. We'll provide a link to that at a later time. KP index has been at 0 for the past 15 hours here, and 9 of the hours yesterday as well. So let's take a look at cosmic rays. Here's the Apatity Neutron Monitor, as well as Barentsburg. And we actually do see a downward trend here over the past 30 days at Apatity, and a similar graph at Barentsburg. Slight downward trend over the past 30 days. Also, we're going to look at some more cosmic ray monitors here, such as Athens, Greece, going a little farther south. There's Athens. Pretty flat over the past 30 days at the Athens neutron monitor. Next, we'll look at Mexico City. Flat on the past 30 days there. And we'll look at Oulu, Finland, and DOMC, Antarctica. We won't look at any garbage data, just data that looks real. And there's Oulu, Finland. A downward trend there on the past 30 days at Oulu, similar to Barentsburg and Apatity. There's DOMC, Antarctica. Similar downtrend and a precipitous downtick here over the past 3 days. Monitor those yourself if you like. Just do a search for links to cosmic ray data and you'll find this great site. Next, we'll look at the magnetosphere. And here's the velocity. This is 4 hours of data, by the way. And you can see some variations in the velocity happening there. Next, the density. check out this precipitous drop-off of the density. Bow! That is low density. It's going to pop back up and pop back down. High density shown in dark blue, low density shown in white. Now you can see that very low density is the current situation at the ACE and Discover stations. And also here's the pressure. Let's bring that back. And there you can see more of a normal pressure. And then you can see here a very, very low pressure. Again, associated with that very low density. As if you really reduce the density or really reduce the speed, you end up with low pressure. It's all part of the space weather modeling framework. If you want to read about that, go to the Geospace Magnetosphere Movies page. Go to the bottom, click Details. And you can read all about the space weather modeling framework. Now, once again, the magnetic perturbations on ground scale are back. And we're only seeing activity at this over the Canadian North Pole here, not so much at the Siberian North Pole, as well as at the South Geomagnetic Pole, which is somewhere in the southern Indian Ocean. I'm going to let that play through a second time here. Again, you can see changes in the B field there up at the Canadian North Pole, as well as the South Geomagnetic Pole, which is around here somewhere. Some sudden bursts there associated with big changes in the solar wind. And we can see the proton event is continuing here. So let's bring up the 7-day chart real quick. You can see that uptick in the proton flux starting on Monday. And there's a 3-day chart. Let's look at the 1-day actually here. And it's slowly subsiding here. Normally we show the 3-day chart. There is that. We did see a C-class solar flare happen here right around midnight universal time. We'll show you that in visual format at the end of the video on our HelioViewer SDO movies. Here's a star chart for all you spaced out viewers. It's from in-the-sky.org. I've faced mine to the south, as that is where the ecliptic's located, as well as the way my sofa and this indeed chair faces. And I've drawn in the ecliptic, which is that yellow line on the screen. If you're up before dawn, you may see the moon and Venus, the second and third, respectively, brightest objects in the sky. Venus, my favorite planet, has it switched places with Mars in your mind, the way that I forecasted it on Scrying with Smash, one of our playlists located at youtube.com/smashomash/playlists. Go subscribe to all of them and press the notification bell. And also, don't forget to share with your friends and foes, science noobs and science pros. We don't talk about theoretical nonsense on the channel. We try to talk about things like actual facts. Here's where stuff is located in the solar system. There's where things will be in a week as we approach another new moon. And we will be doing a live stream at the time of the solstice. It's just lucky that our daily space weather video will coincide with the exact moment of the solstice. So that should be interesting. Now going out here to Lagrange point 5, which is located right there. You can see L5, that's where stereo A is located. And here's that coronal mass ejection. Shout out to Mandy Heslin. Thanks for leaving a comment yesterday and informing us of this coronal mass ejection. You can also see Venus in the frame there. That coronal mass ejection, not Earth-facing, but there still is possibility for Earth-facing coronal mass ejections here, as well as large solar flares, especially from sunspot 2786, which is moving into a setting mode. Again, we'll show you that momentarily. And again, that was from Lagrange point 5 at stereo A. Next, the GOES magnetometer. Seeing some pretty erratic readings here. And the Earth's field force line has crossed into the South Pole-oriented heliospheric current sheet. Here's a view of that from the Gong 2 data. This is part of the National Sunspot Observatory. It's derived from 51 ground-based magnetometers as well as ones out at stereo A and B. That's Lagrange point 5 and 4 respectively. South Pole current sheet shown here in red. And I would expect to see more erratic and sawtooth graphs from the GOES magnetometer. Here's the coronal hole field plot from a more earthly perspective. It is derived from the same data, by the way, and this one shows the B field in blue, North Pole-oriented coronal holes in green, South Pole-oriented coronal holes in red. And that coronal hole that's moving into the Earth-facing zone there, you can see right here that that is a South Pole-oriented coronal hole, despite being north of the solar equator. Here's another view which also shows you the non-colorized magnetometer information. And here's a magnetic field plot of the solar corona. Lots of closed potential field surface source lines there in pink. Open potential field surface source lines in black or in purple, depending on their location. And the earthquake risk has not subsided, folks. We've got an ongoing earthquake watch here as a result of the incoming solar protons. We'll cover earthquakes and volcanoes momentarily. First, we'll look at electrons. We don't see charging hazards. Here's the one-year chart of electron flux. We still are at pretty high levels. We did make it into warning levels yesterday. We're expecting a little higher levels in the next 3 days. There's the NOAA forecast for electron flux. And there's the 3-day chart, just barely making it into warning levels yesterday. I think it was something like 1,600 pulse flux units. Warning levels start at 1,000 pulse flux units, which is that dotted red line. And we see some anomalies here, some serious anomalies happening. This is the total electron content forecast. It shows you the whole air column. And this is some legit data here. As this ongoing proton event continues, although it is subsiding, we are getting major anomalous electron flux regions here happening. You can see some over Antarctica, as well as major ones over North America. Normally these are constrained to the area around the equator, which is where you would see the largest GPS errors, especially at, say, 11:30 until 1:30 p.m. local time. And that's just a diagram of the atmosphere there. We like to include this so that people understand the deabsorption region, the F layer, which is where the GOES 16 makes its measurements, or at least attempts to. And here is a visualization of the F ionosphere layer. And we show this data daily to help immerse our viewers in it and attempt to tie the physics together. It's not known where the Earth's geomagnetic field comes from, and even the electron flux isn't fully understood. How the Earth's Van Allen belts are generated, for example. Ionosphere not looking particularly anomalously right now. A little bit anomalous there, sort of charged up in the southern hemisphere, which is where you'd expect additional charge-ups to happen as we approach the solstice, where summer begins in the southern hemisphere. There's our latest image, 10:15 Universal Time. And we see some anomalous readings happening here with the deabsorption predictions. So those look like some bad measurements there. I would not expect it to be suddenly shutting down and shutting back on, turning back on like that. We don't see quite as much absorption as we saw in the previous days, another indication that the proton flux is slowly subsiding. And it is indeed taking its good old time. Just keep in mind, folks, the earthquake risk does not expire. Let me put that back to where it was, as this is kind of a slow animation. Anyway, you see those major high-frequency absorption zones around the poles. That's a result of that proton flux. Next, looking at volcanoes, and there is a huge list. Kluchevskoy producing a 23,000-foot ash plume. Abiko, 10,000-foot ash plume. Sakurajima, 5,000-foot ash plume there over Japan. Suwanosejima exploded. It's produced a 5,000-foot ash plume. Mount Ibu, 7,000-foot ash plume. Luatolo exploding. Flight level 100, that's a 10,000-foot ash plume. Tokono, 7,000-foot ash plume. Korovin has been decreased in terms of its alert level to green and normal. That's out in the Aleutian Islands. Popocatépetl still exploding. 21,000-foot ash plume. Fuego exploding. 15,000-foot ash plume. Sangay exploding. 22,000-foot ash plume. Revenador exploding. 14,000-foot ash plume. And Sabancaya intermittent puff emissions are a reminder to not attempt to pole vault the caldera. We see a lull in earthquakes, not an uptick. Over the past 24, nothing over a 6 magnitude. We saw some deep quakes, such as this 4.1 at Japan at 1446 yesterday Universal Time. It was at a depth of 137.6 kilometers. I think this might have been the largest of the past 24. Located near Fiji and Tonga at the Loyalty Islands. Here's a deep quake at Indonesia, a 5.2 at 127 kilometers. And we're just scrolling up the list. There was actually an earthquake in New Jersey that was reported by the local news near Milford, New Jersey. I think it was a 2.1 magnitude. Nothing to write home about there. There's a deep quake in South America coming in at 4:06 Universal Time, a 5.1 magnitude at nearly 200 kilometers. Very deep quake in Indonesia at over 550 kilometers depth and a 4.1 magnitude. Here's 2 deep quakes happening only minutes apart at totally different parts of the world. A 4.5 at Timor-Leste, 333 kilometers deep, followed in short order about 15 minutes later, about 20 minutes later, a 4.9 magnitude at Argentina. Fiji Islands see a deep quake at 4.3 magnitude, and the Bande Sea sees a 4.8 magnitude, 403 kilometer depth quake. And again, the earthquake risk continues, especially with the proton event that we're seeing. If you're in these zones, hopefully you'll be an asset, not a liability, when a major quake happens, as we've seen a drought, an extended drought, especially of 7, 8, and 9 magnitude quakes. Next, we'll look at pressure cells. And that's why we're at windy.com. There's where pressure cells are now. And we'll advance this until tomorrow about noon. There's where they'll be tomorrow noon. And we're going to have a major rainout. And check out this powerful low here over the northern Pacific. Check out look at all the bars. See how close they are together? An indication of a massive pressure gradient. High pressure dominating the central Rockies, as well as the central Atlantic. Windy.com, they've got a great mobile app, and no, I'm not paid to tell you. I've got it on my phones. It is free, and it provides a ton of quality data. Let me just remind you once again, that we will be streaming live at the moment of the solstice. We want to be the first channel to wish you a happy winter, or summer if you're located in the southern hemisphere. A happy solstice, period. Where will you be in 16 days and 23 hours and 30 minutes? Where will you be on December 21st, 2020 at 5:02 and 20 seconds Allentown time? Next, looking at the jet streams here on nullschool.net. There's where they are in the eastern portion of the planet. Here's the western world. And looking at the jet streams, by the way, folks, if you're a new viewer, if you're a meteorology noob, the jet streams provide a very good snapshot. And if you want to look at these yourself, head to nullschool.net. It's the 250 hectopascal winds. It requires a lot of computing to get the data, but it's well worth it. We still see this split in the jet stream happening over the central Atlantic. And you can see an anticyclone west of Portugal. Next, lightningmaps.org. We'd like to see where the lightning strikes are happening, as it is part of the data we cover on the regs. Our daily space weather videos are totally oriented toward data and not totally oriented toward nonsense. It's the way to do it. I like to use lightningmaps.org when I hear thunder to convince my foes that I'm Thor and that I'm causing the thunder directly. Here's the NASA GOES lightning mapper. And we see some happening over there in Mississippi. Let's look at some more meteorological stuff, such as the U.S. Doppler radar map. And so we see some heavy storms here over Tennessee, Kentucky, Mississippi, and Alabama, as well as some activity there west of Florida. And Pennsylvania is getting some more snow in the western portion. And tomorrow is going to be a rain out. Shout out to all of our local viewers. And for our non-local viewers, if you're wondering where we're located, smAsho staff and I are located right there in Lehigh Valley, Pennsylvania, something like 12 miles west of New Jersey. Next, looking at the cloud layer, despite the fact that it's still dark out. And if you hear that rumbling sound, you hear that rumbling sound? That is the sound of the smAsho bunker. Perhaps I'll share with our patrons at patreon.com where that sound comes from. Sorry, the rest of you viewers, we can't tell you. It's a smAsho secret. Patreon.com/smAshomash. And here's the water vapor map. Cloud layer. Still a bunch of low clouds over the Atlantic Ocean there, along with higher clouds moving over top of them, and you can see a great view of that. There's the water vapor map of that same scenario. And the water vapor map shows us even water vapor not condensed onto clouds. And we'll actually zoom in on Alabama and Mississippi for our Gulf Coast viewers. It'll also show you Florida. And the Gulf. So there's a good view of that in water vapor. And it looks like those systems are taking their time there. Some rapid cloud nucleation there happening south of New Orleans. Creating some interesting weather. If you're down in that region, go out and look to the south. you may see some interesting cloud formations. They're not chemtrails. They're not even contrails. They're normal atmospheric features. By the way, thanks everybody for flying American Smashways. It's about time for me to vanish and show you bonus features such as the intensitygram, the colorized magnetogram, and our HelioViewer movies for the day. There's the colorized magnetogram. There's that monster sunspot 2786. I believe this one here is 2790. And that active region there is not a sunspot. Here's the intensitygram. Great view of those regions. There you go. Oh, and I see Umbra. We may have a new sunspot forming here. There are some dark spots. It could be 2791. And next we're going to go to our HelioViewer movies to close things out. Here's a one-day animation in 1700 angstroms. So we've got three named groups there on the Earth-facing solar disk. Possible new sunspot forming there in the southeast. Here's a close-up of the southern hemisphere in 171 angstroms. My personal favorite wavelength. And that C-class solar flare came out of sunspot 2790, which is this one right here. And again, that happened right at midnight, Universal Time. Here's 335 angstroms, which is pretty good at showing solar flares as well. Thanks to our patrons, the true source of funding for the content, patreon.com/smAsho if you want all kinds of early updates and all kinds of other perks. Consider becoming a patron at patreon.com/smAsho. Thanks to our patrons. And last but not least, a 193 angstroms full disc video. And you can see that significant coronal hole there. So we've got some activity on the way. Protons coming out of that coronal hole should be here in about 3 days. And it's about time for me to not be here. Thanks for tuning in. Remember, stare at the sun, don't drink it. If you do, don't drive. And since it'll never be now again, welcome to the Neo-Renaissance. May that solar wind be at your back.